In this part, I'm going to show you some more examples on how to do the definite integration to find area of revolution, the volume of revolution. So here on the screen we have the same graph, right? The graph is y being x squared is the same. And the point is 2, 4, right? It's the same on both sides. But on the left hand side, I'm doing a revolution about the y-axis. Whereas on the right hand side, I'm doing a revolution about the x-axis. So you can see, even the shape of the object after the revolution is different. On the left hand side, it's kind of like a bowl shape. It's kind of like the shape of a container. Whereas on the right hand side, it's kind of like the shape of a trumpet. So well, if we do the revolution about the y-axis, then the rotation element will be a disk, and the radius of this is x. Alright, so this is x, so it's pi x squared, and the thickness of the disk is dy. So we do an integration from the smallest y is 0 to the largest y is a 4, because this point is 2, 4. Alright, so when x is 2, y is 4. So we do the integration from 0 to 4. This is the volume of this particular object, right? And the x squared equals to y. So this is simply from 0 to 4 y dy. And y dy, the integration will be y squared over 2 from 0 to 4, and the answer goes to 8 pi. Alright, this is the volume of this bowl. Whereas on the right hand side, we do the volume of the trumpet. Now it's the same graph, but because we are doing the revolution about the x-axis, so that would be pi y squared dx, each of this element. The height is y. After the rotation, it becomes a disk with the radius equals to y. Alright, and the thickness of the disk is dx. So we do it from the smallest x to the largest x. So x is 0 to 2. Alright, pay particular attention to these boundaries. Pay particular attention to this boundary, whether we should use boundary for x or boundary for y. Alright, depends on whether we are dy or integrate with dx. Alright, so y squared will be x to the 4th power. So that is 0 to 2, x to the 4th power dx. And that goes to x fifth divided by 5 from 0 to 2. And that volume goes to 32 pi divided by 5, right? The answer is totally different from that on the left hand side, because naturally they are different areas. Alright, so this is one example. The same curve, the same point, but if you revolve about y, revolve about d, revolve about x, you have different answers, you have different shapes. Okay, so that is the first example in this part. The second and the last example this part will be a trigonometric graph. We have y is sine x, right? So I want to revolve the region shaded in red above the x-axis. So what you see will be something, like some of these candies stacked up together, right? But of course, only 2 of them, right? It will be like 2 of these candies stacked up together. You will have a shape kind of like this. Alright. So now because we take the square of the radius, so it doesn't matter whether it is plus y or minus y, it doesn't matter. They are y nonetheless, or plus minus does not matter, because we are aiming at pi y squared dx. Alright, that would be the volume. We integrate from the smallest x equals to pi 0, right, all the way to x equals to 2 pi. So the integration is from 0 to 2 pi. Alright. Now that would be that is the volume. That would be the integration from 0 to 2 pi sine square x dx, because y is just sine square. Now, like I said before, the integration sine square and cosine square dx, that happens in a lot of this area and volume integration, right? So I think it's worthwhile to pay particular attention to this integral. We use the trigonometric identity to help us. In particular, we use cosine 2x to help us deal with sine square and cosine square. On the other hand, for cosine square x, we use 1 plus cosine 2x. divided by 2, alright, to help us. But for sine square, we use 1 minus cosine 2x divided by 2. Alright, so this answer goes to this one. You may want to pause the video for a while and try to work on it to see how do we arrive from this one to that one, right? But it would be beneficial if you know how do we deal with sine square and cosine square, the integral of sine square and cosine square, right? So you may stop for a while and think about how do we arrive from this line to that line, okay? Oh, right, well, let's come back to here. So anyways, we have this. We have half x minus 1/4 sine 2x, alright, from 2 pi to 0, alright. So whether x is 2 pi or x is 0, this sine term will be 0. So that leaves only the first one. And the answer of this will be pi square. Alright, the answer is pi square for two of these two candies stack up together. Two of these M&M or like Mentos candy stack up together. The volume will be pi square. Alright, so these are some of the examples about volume of revolution. Alright, so in the next video, we'll talk about hollow solids.